In this lesson, we're going to learn about base E and natural logs. For those of you that have had this in science already, this should be a little bit of a review. I'm not sure how much you guys actually cover. But we're going to talk about base E, and you'll notice the first thing in your note says E is a symbol that represents the number 2.71828. It's like pi. It's an irrational number that doesn't end and doesn't repeat. So if we would graph 1 plus 1 over n to the n. So I'm going to graph just that specific function, which seems like nothing to you. It happens to be a formula for continuously compounded interest. And so when I look, that's the one I chose to use. There's several I could have used here, but for this one, when you look at this, I put it in my screen as y equals. So you'll see how I did that. And when I hit graph, you'll notice that it looks like an exponential equation, right? And so when I check, it says as x gets really large, it's going to get close to this number, which is e. So I'm going to look at my table, and I'm going to look as x is getting larger, what's happening to my y. So my y is going to get closer to the actual e value. So notice how it's getting higher and higher. We're looking for 2.71. So as I keep going, notice how it's increasing by hundredths every few buttons I push. And now it's getting to be a few more. I'm almost at 2.71. Oh, it's going even slower now. Look how long this is taking, right? Oh, there we go, 2.70. And it's stuck because I'm freaking out on it. I'm not touching it anymore. You guys look at that red go. Let's try this. Second, table set. I might have just froze my calculator by pushing too many buttons on the screen. Okay, I'm going to come back and show you this when my calculator is not really upset with me for pushing too many buttons. Let's see what happens here. Yep, it's really not doing well. Okay, hold on. Let's just exit out of this once. Or not. We'll just keep going. I'll try to come back to it, see if it clears. But what's going to happen is when I get really, if you punch in, like, go to 1,000 or 1,500, you're going to see it's the number 2.71, but it never goes higher than that. It just gets really close to it. So that's our asymptote, if you want to think of that. That's where that's happening. So why do we worry about this number? Many natural phenomena occur with this number as a base. So many that we store the numbers in our calculator. Things like compound interest, radioactive substances, population models, and lots of other things. So you could use this in science classes mostly. I mean, we kind of consider pi to be the math number and e to be the science number. We also could use this in statistics. If you get into upper level statistics, your population models and using e is something that you're going to do, which is actually like in our AP stats class. If any of you are taking that, that's the last chapter we cover. So we do some logs in there covering things like that. So because of that, when we have a log base e, so our base is e, which is e, remember, is not a variable. It is this number. So it's kind of like saying log base pi. Remember, we are so good at thinking of pi as the number 3.14 because you've worked with it a lot. If you haven't worked with e, you're going to be thinking of it as a variable. But remember, it represents the number 2.71. So we call this the natural log. And we're going to do some properties of natural logs today. When you use the natural log, instead of writing log base e, we write ln for natural log. Why it's not NL, I have no idea. I've actually looked it up and they won't tell me anywhere. But that's the same as log base e. So you can replace that when you're first learning about it, and it's read the natural log of x. It means log base e of x equals y in log form, or e to the y equals x in exponential form. So we're going to first use our calculator to find some of these. So the natural log of 4, let's see if my calculator, oh yeah, it's really not happy with me. Okay, let's just try to open it up again. Sorry. So I'd like to show you where the natural log button is on your calculator. Maybe. For those of you who have your calculators out, the natural log button, we'll see if this opens, is, no, I completely killed it, sorry. You're going to push on your calculator. It is the second log button. So look at your log button. No, I'm sorry, it's right below the log button. So where we did log the other day, ln is right below that. So to find the natural log of 4, I would push the ln and then 4, and you should get 1.3863. And really, these should be approximately similar, shouldn't they? Because we have to round. So hopefully you see where that button is, and that's all you have to push. It's just the natural log instead of a log. And what that means, to put it in other terms, would be I'm going to replace this log, natural log, with log base e. So you kind of get the hang of it. What this is saying, and this is in form, to move it to exponential form, I'd say it's e to the 1.3863 equals 4. So e is also on your calculator, and we're going to use that today. That's the second ln button. You'll see it says e to the x on top of that. That's also going to be used later today, so just so you know where that is. You could punch in e to the, and then your unrounded 1.38 value, and it should say 4, or very close to it, depending on how you're rounding. So I want you guys to try number 2. Number 2, you hopefully get negative 2.9957, which would be the same as saying log base e of 0.05. This is what we just found. So if I want to change to exponential form, it would be e to the negative 2.9957 equals 0.05. So we're going to be changing forms with these again. Here, write an equivalent exponential equation. So remember, the natural log is the same as log base e. So to move from logarithmic form to exponential, I'd say e to the 0.6931 equals x. Same thing here. It doesn't say log base e, so you might have to replace it. This is saying e to the x equals 45. So there is my moving from logarithmic to exponential form. And then now we'll move from exponential form to logarithmic. So this would be log base e of 5 equals x. And we're not allowed to leave it like this in any of our answers. In your work, that's fine. But in your answers, you have to replace it with the natural log. So we'd say the natural log of 5 equals x. 6, log base e of 3x equals 5. So we'd write the natural log of 3x equals 5. Ideally, we're going to get to the point where I'd like you to not have to use this step at all. You go straight into the natural log form. But I want to show you that because I think it helps when you replace it with log base e. It looks a lot like the other ones we've done, and I think that helps kind of stick with it. So what do you think the natural log of e is? So think of this. If I was going to change forms here, this would be log base e. So it's saying e to the x equals e. So what would that be? Hopefully you realize that this is e to the first, and since we have the same base, we would say x equals 1. So the natural log of e is 1. That's just what we're finding out there. That's a property that comes up sometimes. The natural log of 1 then would be e, because this is log base e, right? E to the x equals 1. Well, what to any base to what power would equal 1? Hopefully you remember that that's 0. E to the 0, anything to the 0 power is 1. So we'd say the natural log of 1 is 0. Another one that comes up sometimes that you just have to kind of remember or solve this way, that would always work. So now we're going to actually apply all these same things we've learned about logs, the whole chapter, we're going to now apply to natural logs and e's. So to solve this one, I can't plug in e to the x on my calculator. So whenever we're stuck, remember we're supposed to change forms. So I would say this is log base e of 3 equals x, which is like saying the natural log of 3 equals x. I can punch in the natural log of 3 in my calculator, and I would get x to be approximately 1.0986. So there's how I would solve number 9. Number 10, same idea, except that first I want to get the e to the x by itself. So I'm going to divide both sides by 4. So I have e to the x equals 17/4. So now when I change forms, I'd say log base e of 17/4 equals x. So the natural log of 17/4. I punch that in my calculator, which I would show you if it was working. But the natural log of 17/4, you should get approximately 1.4469. If we move on to number 11, we always want to get the e by itself before we change forms. So I'm going to add 7 to both sides and get 9. And then I'm going to divide by 5. So when I change forms, I'm going to say log base e of 9/5 equals negative 2x. So the natural log of 9/5 equals negative 2x. So I'm going to find the natural log of 9/5. Whatever that is in my calculator. I actually didn't write this down, so let me look it up quick. the natural log of 9/5, I got 0.5878. And then to solve for x, I'd have to divide by -2. So I ended up with negative 0.2939. And hopefully you guys got that also. If you look at number 12, this says the natural log. So it's in this is in logarithmic form. The ones we've just been doing have been in exponential form. Those are all in exponential form. Now we're in logarithmic form, so it's not going to work for me to plug in natural log of x in my calculator. You actually would get an answer, just so you know this, because your calculator has a value stored for x. It wouldn't be the right answer, though, unless by odd luck you have the right number stored, which I really doubt since it's a decimal. So we're going to change forms here. We'd say log base e of x equals 4. When I change to exponential form, I'd have e to the 4th equals x. Remember, e is the number 2.71. So you're taking that number to the 4th power, and you do that on your calculator. So I'd go second ln, and you'll see the e pops up, especially if you have the update. And then when I enter a 4, I get 54.5982. Hopefully you guys got that also. Number 13, same idea. I'm going to change my form, so I have log base e here. So I'd have e to the 7th equals 5x. When I plug e to the 7th into my calculator, I get 1096.6332, and that equals 5x. So I'd have to divide by 5, and I got x to be 219.3266. Hopefully that's what you guys got also. So we're going to keep going here with all these different log ones. Number 14, here's my log base e. So I have e to the -2nd equals x minus 1. When I plug in e to the -2nd in my calculator, I get 0.1353. And since that was x minus 1, I go ahead and add 1 to both sides. So I get x to be approximately 1.1353. Last two in this section. Here you'll see that we have this addition problem here. And this would be part of the product rule. Because I don't have a log base e in all three spots, notice it's not there, I can't just set them all equal and do the multiplication. So I'm going to say that I have the natural log of 3x times 2x equals 9. Remember, this is log base e, right? So when I change forms, I'd have e to the 9th equals 3x times 2x. When I plug in e to the 9th in my calculator, I got 8103.0839. And that's going to actually equal 6x squared. I'm just going to go ahead and take that 3x times that 2x. So what I would do is I would first divide both sides by 6. So I do that on my calculator again. And I'm getting 1350, 5140 is what x squared equals. So we're going to square root both sides. And I get x to be approximately, I got 36.7493. I would get a plus or minus here, but remember we can't have a negative log. So I'm not going to write plus or minus, I'm just going to give the positive value so I can keep that positive log there. And then the last one we're going to do with these type of problems, I have another addition, but hopefully you notice that I have to apply the power rule here. So I'm going to first move this 10 out here and move this 2 out here. So I have 2, oops, sorry, wrong side. I have 10, oh, hold on a second, let me start this over. I'm going to use the power rule right here and put this 10 in front. This is being quantity squared. There's a difference, there's parentheses here, and this is the one that's going to be kind of confusing for us. I'm not going to do anything with that because it's the quantity squared. So we're going to leave that alone. But by moving that 10 out here, I'm going to now subtract 10 natural log of x's. And I end up with 0 equals the natural log of x quantity squared minus 10 times the natural log of x plus 24. Now if I wasn't doing logs. This problem, let's replace the natural log of x's with just x's. Would look like this. That looks like a problem we could factor, right? So we are going to do that because the natural log of x times natural log of x makes natural log of x squared, right? So we can factor that. I'd have the natural log of x for both of these, because when you multiply them you get the quantity squared. And then factors of 24 when added together make negative 10 would be negative 6 and negative 4. So as I keep going with this, I'd say the natural log of x equals 6, the natural log of x equals 4. Now here is where I can't plug this into my calculator, so I need to change forms. Remember, natural log is log base c. So for this one I actually have e to the 6th equals x, and this one is e to the 4th equals x. When I plug those values into my calculator, I'm going to e to the 6th, I got 403.4388, and then e to the 4th is the 54, I think we did this one earlier, 5982. Now, if I remember right, on your Excel math, they actually leave the answers like this. So that's what you should look for. I would expect you to find those if we were taking a test. So either way works in Excel math. I believe they leave them like this. But I would expect you to actually find that e-value on a chapter test. Our last problem then you'll see is a word problem. It says the number of a certain product that will be sold t years after the product is introduced is given by this function, n of t equals 2600 natural log times 6t plus 5. How many years after the product is introduced will 8800 be sold? Round the answer to the nearest whole number. So time is years, right? T is years. So n of t would be number of years after the product is sold. So how many years after the product is introduced will 8800 be sold? So n of t here is what I'm going to plug in the 8800 in for. So I'm going to say I have 8800 equals 2600 times the natural log of 6t plus 5. So I now need to solve this equation for t. And remember, my only variable is t because ln is the natural log. So to start, I'm going to get the natural log by itself. So I'm going to divide by 2600. I then have 44/13 if you reduce it to a fraction, times the natural log of 6t plus 5. I can't plug in the natural log of 6t plus 5 because I have a variable, right? So remember, this natural log is log base e. So I really have e to the 44/13 equals 6t plus 5. So as I continue to solve this, I can find e to the 44/13. So I'm going to plug that in my calculator, second natural log, and then I'll go 44 divided by 13, and I got 29.5066 is approximately 6t plus 5. So now I'm just solving this for t. So I'd get 24.5066 equals 6t. When I divide by 6, I got 4.0844. This would be my answer, except it says in the question, round the answer to the nearest whole number. My nearest whole number is 4, so my time is approximately 4 years. Make sure if any of that doesn't make sense to you, tomorrow in class you ask me for help on any of those things that you're confused about.